All right. Let's pick up where we left off yesterday with 2-7. Okay, so 2-7. Yesterday you guys got all those rules for transformations on the back of your big idea worksheet. And today we're just going to use it a little bit more. The last thing we did yesterday was you had an equation and you had to name the transformations that occurred on the parent function. This next group of problems is just the opposite. We're going to have the list of transformations and we're going to list or create the equation that will create those transformations. All right, so again, we'll do 3 together and then you can try the 3 on your big idea worksheet. So you want to make note of first what the parent function that's being transformed is. In this first problem, the parent function is square root x. So that's what I'm going to start with and add my numbers to. That could change from one problem to the next out of the 11 that we've talked about. We want to take this and we want to shift it 2 down, reflect it over the x-axis, compress or shrink it vertically by a factor of 1/2. So you can do this in several steps or you can do this all in one step. I think it's easier just to do it all in one step. So I'm just going to create a big square root function and put an x under it. And for every transformation that occurs, I'm just going to add the appropriate number or negative sign in the appropriate place. All right, so if I want to shift it 2 units down, and this is where you can use your chart, what do I need to put where in this equation to make the square root function move 2 units down? Outside, okay, is it going to be added, subtracted, multiplied? Subtracted on the outside. The d value outside of our parent function will move it up or down, in this case down if it's a -2. I want to reflect it over the x-axis. So reflections are negatives. If it's over the x-axis, do you want to put it inside or outside? Outside. Negative out front. And then finally, we want to compress or shrink vertically by 1/2. If it's a vertical stretch or shrink, is that outside or inside? It is outside. And we just use that exact value, 1/2, and that is your answer. Now it's a little, big how I've written it there, but that is the solution. Okay. All right, let's try another one. Graph of g of x is x to the 3rd, and we want to shift it 4 left, stretch vertically by a factor of 3, reflect it over the y-axis, and shift it 2 up. And I guess I should probably use the proper notation, so I'll just adjust this one, f of x. My next one was g of x. All right, so we are starting with the cubic function. So I'm going to put a big parentheses, cubed with an x in it. Okay. 4 to the left. If you want to move it left, okay, inside the parentheses, is it going to be a +4 or a -4 if it's left? +4, good. Okay, we want to stretch it vertically by a factor of 3. What do I need to put where to make that happen? 3 on the outside, good, multiplied. Reflection over the y-axis, negative outside or inside? Inside. Now be careful here. Remember that if we have something in front of the x, it needs to be separated with a parentheses. So I'm going to take that x plus 4 that I already have, put it in parentheses, and the negative in front of it. Option number 2 is you can distribute that negative into the x and the +4. But either way, it's technically a -4 now that's in there. And then what do I have last? Shifted 2 up, +2 at the end. Final answer. I believe in Math Excel, you will need to distribute that number or negative through when you type in your answer. So just make a note of that. I'll accept it either way, though. All right, last one we'll do together. H of x is an absolute value function. So h of x equals absolute value of x. First thing I want to do is shift it 6 to the right. How do I do that? Inside, plus or minus, if it's right. -6. There we go. Compress horizontally by a factor of 1/3. Horizontal stretches and compresses, are those outside or inside? Inside. Now, horizontal ones are the tricky ones. Be careful. If it is a number bigger than 1, it shrinks. It compresses. And if it's a number smaller than 1, it stretches. So if I put 1/3 in there, it's not going to compress it, it's going to stretch it. So the horizontal stretches and compressions, we use reciprocal values. We're going to put a 3, and again, I'm going to separate my x from that 3 with the parentheses. That will perform a compression, okay? Only the b value do you have to worry about doing that. It's a reciprocal. Reflect over the x-axis. Negative out front. 3 down. Minus 3. All right. Head to your big idea worksheet. You guys try a couple of them. Try the 3 at the bottom there. All right, bottom one's a little tricky. Anything that is near the x is happening inside the function. So it's almost like what we would do with the squaring function, but there's a 1 over it when we see that reciprocal squared. Any questions on those? Okay, remember in Math Excel, if there's that number in front of the x, you may have to distribute it in before you type your answer. Save you an attempt, maybe. All right, so now that we've practiced naming our transformations from the equations and writing the equations from the transformations, we can practice transforming actual functions. So let's say I don't have the equation now. I don't know what the equation of this is. This is not one of our parent functions. It's a piecewise function. It's got 3 different pieces. I don't even want to try to transform a piecewise function. That sounds terrible. So in general, if we want to do transformations, we can do them by hand. We can physically move the point. We can take points and we can shift them left and right. We can shift them up and down. We can move them away or towards the x-axis to do stretches. Same with the y-axis. We can do reflections. We can do all of those things. And what you need to write down is this right here, where it says 1, 2, 3, 4. If you perform transformations by hand, you must complete them in this order. Think of it like the order of operations for transformations. Okay. Sometimes you'll have all 4, sometimes you'll just have 1 or 2, but if you do not complete them in this order, you will have an incorrect answer. So we're going to do a left-right shifts first. Then we're going to do our stretches and compresses, and actually reflections. Those kind of happen at the same time. And then our vertical shifts last. It's pretty much if you plugged a number in for x in the equation, what would affect that x first? Well, the first thing you would do is add or subtract from that x. That would be our left-right shift. And the next thing you would do is multiply by the numbers in front, which would be your stretches and compresses and reflections. And the last thing you would do to calculate something in these equations is you would add or subtract the number at the end, which is those vertical shifts. So that's where this is coming from. All right, so in this picture, I have 4 points that are labeled on the graph. So we're going to use those 4 points to transform this, and we're going to do 2 of them. So go ahead and write down these 4 points: -5, -3, -1, -1, 1, 3, and 4, -2. Make a rough sketch of it if you want on your paper. We're going to take f of x and we're going to transform it into g of x. And g of x is this guy here. All right, so the first thing you need to figure out from g of x, even though we don't have the whole equation, is what does that 1/2 and that +1 do? If you have a 1/2 multiplied in front of your parent function, whatever it is, what does it do? It is a vertical what? Shrink by 1/2. In this case, that's what that 1/2 does. I also have a +1 at the end. What's that going to do to this graph? It's going to move it up 1. Okay, so I know the two things I have to do with my sets of points. I'm just going to sketch those points one more time. -5, -3, -1, -1, 1, 3, 4, -2. And there's arrows at the end of it. Okay. All right, I need to do those two things. Which one is going to happen first? The vertical shrink or moving it up 1? According to my little order of operations up there. Do I have any horizontal shifts here? Horizontal is left, right. Do I have a horizontal shift? No. Do I have any vertical stretches or compresses, horizontal stretches or compresses? Yes, I do. That's what's happening next. I have a vertical compression. I have a vertical shrink. So we're going to do that first. And then I don't have any reflections, but I have a vertical shift. So we'll do that second. So now I know what to do first and what to do second. Okay, to perform any stretches or compresses, think about the taffy we talked about yesterday. If it's vertical, you're going to pull it away from the x-axis or push it towards the x-axis. If it's horizontal, you're going to pull it away from the y-axis or push it towards the y-axis. In this case, it's a vertical shrink. So I'm going to take my points and I'm going to push them towards the x-axis half the distance. That's what this does. So if I have -5, -3, and I want to move it half the distance to the x-axis, if I want to push it towards the x-axis, where's it going to end up at? -5, -1.5. It's going to be half the distance. If I have -1, -1, and I want to move it half the distance to the x-axis, if I want to shrink it vertically, where's it going to end up at? -1, -1/2. This point is how far from the x-axis? 3. What's half that distance? 1.5. And my last point is how far from the x-axis? 2. Half that distance is 1. If you connect those points, you will see the vertical compression. See how it got a little shorter and kind of flattened out a little bit? Okay. Next, we have to take all those points and move them up 1. We're going to take the green one and just move them up 1. That's very quick. So up 1, up 1, up 1, up 1. 4 times in a row. Up 1, up 1, up 1, up 1. Remember, this is called a rigid transformation. It does not change the shape of the graph. G of x, your final answer is the red graph there. Now, I like this method because it's very visual. You can see every transformation happening. I don't like this method because if there were like 4 transformations, can you imagine how messy this would be if you tried to put it all on the same graph? You could maybe put them all on different graphs if you went through it, but it can get a little funky. So I'm going to show you a shortcut. This is optional. You do not have to know this formula, but it can save you some time. You can take the physical points and mathematically manipulate them so you only have to graph one thing at the very end. And how we do that, to transform our x, we do the following. We do our a value times our, oh, I take that back. That's my x, doing the wrong one. Reciprocal of b times our x, and then we're going to add on our c. No, subtract our c. There we go. And then the y, we're going to do a times y and add d. There we go. Our 4 points, -5, -3, -1, -1, 1, 3, 4, -2. In this problem, do I have a b value? a horizontal stretch or compress? We did not. Do I have a C value, which was a right-left shift? No. So guess what? All of my x's stay the same. -5, -1, 1, and 4. Nothing different. My y's are going to change here. What's the A value? What is it? 1/2. And what's my D value? Was 1. Okay? So let's do that math. 1/2 times -3 plus 1. -1. 1/2 times -1 plus 1. 1/2 times 3 plus 1. 1/2 times -2 plus 1. I'm just plugging all of my y's into that formula. Final answer, -5. I'll have -3/2 plus 1, which is -1/2, which is the first point we plotted on the left. I'll have -1/2 plus 1, so 1/2. -1, 1/2 was the second point we plotted. I'll have 3/2 plus 1, which is 5/2, or you can say 2.5 if you want. That's that top point on the red function. And then the last one is 4, and -1 plus 1, 0, which was the last point we plotted. And then that would be the only thing you would have to graph, are those 4 points. Okay, so this formula is how the x's change. This formula is how the y's change, no matter which function you are graphing, whether it's a parent function or a piecewise function or something you have no idea what it is. It's going to be the same rules every time. So they're tiny little formulas, but it can save you a lot of this graphing nonsense. So another problem, I've got g of x over here. I'll write it a little bigger for you. G of x equals -f of 2x minus 2. Okay, we're going to do it with the points only this time. We're not going to mess with the graph. I need to name the transformations. And actually, I don't even need to go that far. I could just name A, B, C, and D. If I can find A, B, and C, and D, I'm good. The only thing I want to make note of, when you use our rules, are you allowed to have a number in front of the x? So I've got to factor that 2 out first. It's still staying inside of function f. There's just going to be an extra parentheses now. If I divide 2 out of 2x minus 2, I am left with 2 quantity x minus 1. All right. Can you tell me what the A value is? A is a -1. So A is technically a 1. The negative will also do the reflection force. It's the number out front. B is +2. Number in front of my x. C is a -1. It's a number added or subtracted on the inside. D, do I have a D in this problem? Up, down? No, I'm just going to say it's 0. Okay. So to transform my x's, we're going to do the reciprocal of B minus C. The reciprocal of B is 1/2 x minus C plus 1. To transform our y's, we're going to do A times y plus D. A is a -1 times y plus 0 in this case. Okay, with your groups, you can do this on your paper, back of your big idea worksheet, whatever you want. Take those same 4 points we had in the last one and transform each of the x's and y's to figure out where the final graph's going to lie. Okay? Go ahead. So take each of your x's, run it through the x formula. Take each of your y's, run it through the y formula. You can organize it however you want. It's minus C, and C was already a negative. So it's minus -1 there. So it's always going to be the opposite of your C sign. All right. So here are the 4 points we started with on the left. And after I run the x's through here and the y's through here, I end up with this. The y's just change sign. That's a quick one. Yes.
For the second point, would it be positive on that?
What did I do? Negative a half plus 1. Yep. Thank you. Positive half. So then that is going to change. Positive half 1 is going to look more like that. Good. Okay. It's not too bad if you can find your A, B, C, D, same formula every time. Or you can move the points around. This one, you'd have 3 different transformations. You'd have to move them right 1. You would have to do a horizontal compression, so you'd have to move it half the distance to the y-axis, and then you'd have to reflect over the x-axis, which you can definitely do. And you can hopefully see all those transformations that are occurring here. At least the reflection you should be able to see over the x-axis, and the compression horizontally. You can see it's a little skinnier than it started out being. Right, it's a little difficult to see in this picture, but okay. So whatever way you prefer to do it. If you want to physically move the points in order, you can do that. If you want to use the formula and transform the points algebraically, you could do that. Questions here? Cool. All right, last problem is actually a Math Excel problem that you're going to see on 2-7. So I want to just kind of walk through this with you. It says, suppose that the x-intercepts of the graph of f of x are -4 and 2. We're going to find the new x-intercepts based on a new equation, a transformed equation. If I have a +5 inside a function, which way does that move it? Left? 5. Okay, now let's pick a graph. It can be any type of function that has x-intercepts at -4 and 2. So here's -4, here's 2, something like a parabola would be a good example to think about. if I take that graph and move it left 5, what's going to happen to my x-intercepts? Aren't I taking every point and moving it left 5 when I do that? Okay, so what does negative 4 become? Negative 4 would be negative 9, moving it to the left. And positive 2, if I moved it to the left 5, would be what? Negative 3. Okay, so we're not going to get overcomplicated with this with like calculations and formulas and things. You can just visualize it, draw a sketch. What if I have a minus 3 inside the function? What does that do? Moves it right 3. If it moves it right 3, can you tell me what the x-intercepts would be? What would negative 4 become if I moved it right 3? Negative 1. And what would positive 2 become? 5. Okay, what if I have a negative outside the function? What does that do? Reflect over x-axis. If I take 2 points that are on the x-axis and reflect them over the x-axis, what's going to happen to those points? Absolutely nothing. It is still negative 4 and 2. Now, what if I have a negative inside? If I reflect over the y-axis? So if I take negative 4 and reflect it over the y-axis, where's it going to end up at? Positive 4. And if I take positive 2 and reflect it over the y-axis, where's it going to end up at? Negative 2. So it's just opposite signs. 4 and negative 2. What if I have a 15 outside the function? What does that do to it? Vertical stretch by 15. Now, again, when we are stretching or shrinking, we're pulling away from the x-axis or pushing towards the x-axis. In this case, we're going 15 units away from the x-axis, 15 times the distance we already were. If I'm on the x-axis, what's my distance to the x-axis? 0. What's 15 times 0? Still 0. If you are on the x-axis and you want to be 15 times more that distance, you're still on the x-axis. So negative 4 and positive 2. If I did a vertical shrink, they would remain the same. Now, if I did a horizontal stretch or shrink, that's when they would change. Okay. All right, so that'll help you with that math Excel question. Just draw a sketch, use a parabola to help you. You should be able to visualize it. Should be pretty quick. All right, homework. 2-7. So let's see when the date Okay, so 2-6, you guys are all done with already. 2-7 is due on the 3rd. That is Sunday night. Remember, tomorrow you have a quiz. The quiz is over 2-4 to 2-7. It is open notes, so make sure you come ready with your big idea worksheets, your notes, notebook, anything that you have handwritten that I've given you a handout for, you may use. You can also use your graphing calculators tomorrow. It is individual. You are not working with partners. All right? I'll do the cell phone lotto. The last 15 minutes are yours, guys, to get started on your Math Excel homework. You can let me know if you have questions. 16 is my winner. Who is number 16? Julia. There you go, my dear.